Hello and welcome back to the last session of serde-yaml for today. It's Baron speaking, and the reason why I'm actually doing this is that I think I finally understood how this is supposed to work. It's always this stuff with non-printables. Let's get cute creator here. Where is it? It's this one, lib-yaml. Oh, come on. Did it really not remember the last open file? That's sad. I think it was in emitter, just because you had about 2000 something there. We have the implementation of escape string and also analyze string, right? Analyze is here somewhere. Somewhere. Oh yeah, there it is. Analyze anchor, analyze scalar. That's the one. Anyway, this is not what I was trying to get at here. It is implemented. Awesome. Anyway, what I was trying to say is that this is printable always confused me, and the thing is, what matters is really what's written here. Right? And the only thing that we have to escape is these special characters, and that is it. And everything else, where is that actually? Where have I read it? Double quoted style. Yeah, I think it is somewhere. At least I've read that actually it can handle everything except for the few listed control characters. And you are actually supposed to, yeah, here. I think it is here. C printable. Actually, considering I have this here, I might just use these ranges, huh? What I try to say is, technically, we can print everything because look at that. I was just trying out a few things. I was trying Chinese, some Chinese character. So if we dump it, it will declare it non-printable. But guess what? It is printable. If you're in China, it's totally printable. The cool thing is that if we load this thing, oh yeah, that's the wrong one. Then JSON can load it as is, as well as YAML. So why would we want to escape this thing then? Why? I don't get it. So let's see. The dump stuff gives me 597D. And is this in this range of printable characters for him? 5. Totally. It's totally printable. So I don't know why it will then actually not do it. Yeah. So the question is, yeah, I didn't actually expect this. I was just saying, well, we only have to exclude control characters explicitly, or not exclude them, but escape them, and then we are already good. And yeah, there are different ways of encoding these. So for instance, for JSON, you would need the surrogate pair stuff because it can only do 16-bit Unicode characters. Whereas in YAML mode, you have 8-bit, 16-bit, and 32-bit. Actually, which is totally awesome. But hey, it's just a way of how we want to encode this, and this is easily handled, or can easily be handled here. What I wonder, I mean, I'm going to deduplicate this, but I probably do this in a separate session. So what I wonder now is, yeah, this for instance, this is printable. 1F600. 1F600. Actually, this wouldn't be printable then, huh? Printable. It doesn't look like it. At least if you, I mean, even the Chinese character is not printable when it's about, when the JSON thingy here can decide. If we dump this, we get 1 F6, so that's totally not printable. But the funny thing is that it can, of course, be decoded because nobody cares. So if I take this here and put it into a string, well, YAML load, then this totally works. And this is what you want, right? And if an editor is able to show it, to display the symbol, then I think you want to display it. So I would actually not do this. Yeah, so I would actually only deal with control characters. So for the demo here, I think what I want is non-printables for now. Printables, we do not escape them as most editors. Show them just fine. And also, interestingly, Chinese characters seem unprintable when looking. Okay, maybe we get some more space here. When looking at the lib-YAML implementation. They deserialize fine though. So this is really all this is about, right? So this is supposed to improve encoding, or the visibility of, or the human readability of strings. And I think it doesn't help in these cases. So I'd say everything is printable unless it's a control character. And that's the new rule here that I want to apply. So here we go. It's just, let's also have the Chinese symbol just to show what I mean. Let's take this and copy it. So here we go with a Chinese symbol, because this is kind of the market that we are targeting. And if you can't do this, then it kind of is annoying. So on that side, what we actually expect is exactly that. We expect this literal character. We could, if we wanted to, also use the encoded version of it, but do it in probably not in a raw string, huh? But do it in Rust like this, right? So that's now exactly this encoded version. And here we would have exactly the same, except that we are enclosed in some delimiters. And I wonder if that actually works, or if it, probably it doesn't work because we are in a raw string. Yeah, oops. So let's try to get this to work. So this is the only test that currently doesn't fail, that currently fails. But I think it's super valid to have and super important to have. So here we go. And all of a sudden, this looks pretty good. Yes. Totally so. Cool. So that should be fine because it's actually not escaped anymore. At least that particular one. Let's see how far we get. Overlong Unicode escape sequence can have at most 6 hex digits. Oh, it's 24. Well, fine. 1, 2, 1, 2. Well, 1, 2, 3, 4, 5, 6. Oh, this is why it's overlong. Huh. Interesting. But that should be fine for us here. So Rust is only valid until 24. Good, so here we go with the 597D stuff. Oh no, wait, where's that? Oh wait, that's Rust symbol, and that's U3D, that's the surrogate pair here. And yeah, we don't want a surrogate pair, we just want this again. Let's take these directly. And yeah, I shall do the YAML version here, and then manipulate it to become JSON. Damn it. No fun. Why is there a tab in here? Is this a tab? No. The editor is just able to skip it correctly. Well. Here we go. That is that. And now it should be easiest. Oh, it's a line break here. Oh, damn it. This is why unexpected things happened. Were happening. So I'm really slow right now. It takes a long time to do this basic editing. Jesus Christ. So let's have this Chinese awesomeness here and here. Like so. What do you say? So that should totally work. And let's try it. Good, and now I need a control character because the next thing we want to implement is this escaping of control characters. Okay, something didn't work. La la la. Oh man. I managed to copy the wrong thing. So actually it's just that. Just 4 byte. 2 bytes, 16 bits, sorry. Okay, this works now. Awesome. So now let's get some control character in the high Unicode range somehow. Unicode control character. Table, why not? But what's the... Maybe here we have already some. Huh. Look at that. A233. Paragraph separator. HTML paragraph. Okay, we know these one, but this one is new, for instance. So the question is, does Rust think that this is a control character? If it would think that, we could break here just for the fun of it. So right now all the tests work, but what if we say, and this is something we try, these are all tested here. So what if we panicked here? Foobar. Yay. I hope it could only warn me that this one line. Oh yeah. Okay. So it will warn me probably that this one line has no effect, but it should fail now with foo. Yes. And actually what I want to assert is this. Is control how was that called again? I hope I still have docs open. Control is control, yeah. Makes sense that it is control on a character, right? Sure, this character is a control kind of type. What? Oh, okay. Now that would be cool because then we could handle this automatically. Oh, so that's not a control character for him. Interesting. So not this one. Probably that neither. 85. Probably neither. Okay, so I don't care. Just keep them as they are. Oh, this one is a control character. Look at that. 85. Nice. 85 we do test, right? Yes, we do. Cool. So this one we could use. Let's try that as well. Like this. And now we go with 28. And maybe this one we try as well now that we're at it. 29. All right, so this would mean that only A0 is required and the rest we can handle with the standard control character encoding clause. No. So 85 is handled by that. But this stuff is white space, huh? That is why it's not a control character. It's weird that this happens to be a control character. I don't know. Why should I not handle these explicitly? Oh wait, no. Yeah, 2028. Probably it's 2029 as well, huh? I think I will handle them explicitly and just not care. And not try everything. Okay, good. Forget it. So 85 happens to be a control character, but we will just list it explicitly here because it's special to us, right? This is why we have to list it. And because, yeah, that's primarily it. Okay, now we should be back to normal. And yeah, anytime now. I just need a control character, a big one that is truly a control character. Control characters are escaped though also with surrogate pair in JSON. This is it. It's just the way JSON works, right? There's nothing special about a surrogate pair, even though I'm already afraid of having to parse this stuff. Because sometimes it seems, no wait, it's not. I think the YAML stuff can be problematic. Because if there's a number after the Unicode, then it's, if we have a 2-byte Unicode encoding there, and there is a number like 00 afterwards, then all of a sudden it looks like a 3-byte encoding. 24-bit, right? Which is kind of valid, not for YAML, I think. Yeah, YAML wants 32-bit. Oh, wait. Look at that. That's actually 24. This is 16. That's 24, man. This is exactly what Rust does. Probably for a reason, because the values in there can't go that high. That's not 32-bit, but anyway, I was believing you for a moment there. It's interesting to have done that once in your life, I suppose. Let's try to remember as much as possible. All right, so what did I want to check out here? The analyze code. I wanted to see if it handles this somehow, if it has a flag for that. Something with Unicode stuff, preceded white space. No, I don't think it has that idea. Yeah, we can actually try that. We could try to manufacture something. So what if we have a 6-byte? So how did that work here? I think that's like this. Well, 5542. That actually does something, even though I have no idea what kind of character that could be. Especially because it's escaped. So if I do 5522 and then plus 00, then I get this, which if decoded will yield maybe something else. YAML load. See? No, wait. That's interesting. Was this a lucky pick? And how does it know that this is not? How does it know that? That's amazing. How does it work? Oh. No, wait. No, I don't know how that works. Because here we have it encoded. Do we? It looks like it. It looks like it's not part of the string, but as this is also Python stuff, we wouldn't know. Maybe if we put some small f in there, UF, maybe that's not okay. Okay. No, it's a different character, yeah. Yeah, I mean that's definitely a string. That's not interpreted by Python. I was kind of not understanding for a moment. I don't know how it knows that this is already a valid Unicode item here, and that the other stuff is not part of it. I have no idea. This is still something I don't understand, but apparently there's no special handling needed. That's awesome. So we can once again maybe try to find a control character that is actually a control character that is understood as one. So look at that. Introduce separators, control characters. What? Bidirectional text control. That looks good. Look, this is probably a control character, huh? 22E. Let's use it. Nice. That's bidirectional control something character. And yeah, let's have a flag there that we run into. And also that is something that doesn't require a surrogate pair. So I guess we want to have this at least once. Yeah, and I guess I want to have some sort of but then some sort of encoding going on, maybe like that. And where's my 8-byte, my 2-byte, my 16-bit control character? It's here. So yeah, that's that. That's definitely a control character. And this should just yield the same, actually the same on both sides, 22E lowercase, and here it's U22E uppercase, right? That was the thing here. Yeah, do we have it elsewhere, like the uppercase test? Yeah, here it is kind of indicated as well. Awesome. So that should not work right now. But that should also the only thing that fails, just because we have no encoding in there yet for all the control characters that there might be. Expected at least one digit in the exponent. It didn't understand what I meant. Sorry, unit 248. Oh, this is why. I had it pasted it there and then forgot about it. Awesome. Like this. Is it the right one? It's the right one. So we don't encode it at all, but we actually want to encode it. Okay. And now the fun part. Let's do it for JSON, because we have some code for it already. And the first implementation, as usual, is as dumb and shitty as it gets. Let's move this away. I think I forgot to copy parts of that. Totally. Because I wrote so much about this buffer here. Damn it, now I have to rewrite it. Let mud_buff be a string new. Used in hopefully rare cases, so heap allocation won't matter. If it does, it would be easy to pass the buff as argument, so the heap memory can be reused. So that's really it, right? Okay, and now this code. Yeah, so that's the code that is part of the match case here that we will do for JSON. So then see if C is control, right? And now we come in with our fantastic pre-made code. We clear the buffer, and this part should already work here. Oh wait. Actually, yeah, actually this part should already work. So that's just telling us that we fit into the range of 2 byte. It's a 16-bit range here, quite exactly, because this would be 16-bit and we just go one more and then compare if it's smaller. It makes total sense, does it? Yeah, so this means we can actually do that conversion without a loss. I don't know if there's any other way to do this conversion. Can I also cast down to 16 or something? Because that should be enough for this value. And then it might actually crash at runtime if that doesn't work. I don't know. Yeah, so that is that. For JSON should work. Oh. Like that, maybe. Better. Cool. So that is now in 251. Oh no, still the wrong one. Does it mean that it's not a... Oh look, it... No wait, this is what we expect. And this is that. Did I put it into the right spot? Yeah, that's JSON. Are we here? It seems we don't get there. Damn it, don't tell me that it doesn't find this one. It's a control character, it says so. That sucks. We don't get there. So what does the documentation say? Indicates whether a character is a control code point. Control code points are defined in terms of the Unicode general category. General. Unicode general category. Tell me about it. General. Nothing is easy here, it seems. Other. General. Yeah. Excuse me. Each Unicode character assigned a category. This is a complete list of categories. Ah, other control. Actually, it said CC here, right? Of the general category CC. It's not called general category, but it's one of these. So, number of characters 65. Okay. So we could select from here, right? Oh, look. Yeah, so that's basically the rest of the control characters. So these ones we actually get information separator 4. Yeah, so they're all in the lower range. So we will never actually get to that point. Yeah, we could make an assertion there, maybe that. Yeah, let's do that. I'd be fine with that. Then we don't have to do circuit pair stuff. And yeah, that's fitting beautifully into 8-bit. Okay, I see. What's the other category then? Like the line, that may be format, huh? CF. So which one did we pick? We picked 22E. 22E. There we go. Now we're getting somewhere. I'm kind of understanding Unicode a bit better. I had no idea. Okay. Soft hyphen. I think you need massive lookup table if you want to do this totally correctly. Because these are kind of non-printable. If you look at them, that's not part of my font. Tag let in small letter F. Interesting. This could actually be a valid... Oh, it's that. It's a tag F. Jesus. Tag G. Oh yeah, there's an E in front of it. I forgot. This kind of looked like it could be ASCII. Maybe it is. I mean, except for the E part here. All right. Cancel tag. Awesome. That's totally non-printable. And we don't handle it. But you know what? Who cares? Surrogate 6, okay. Non-private use, high surrogate first. Fantastic. High, whatever that is, low. That seems to be some sort of encoding help, format help. Because this tells you what comes first, huh? High surrogate last. Wow. Okay, so I think I'm good. So that private use. What's private use? No way. Ah, private use. This is why. So on a Mac, that's an Apple symbol. And could be anything. Now I get it. Interesting. Kind of sign whatever you like. letter title case, letter uppercase. And where would I find, just for my information, where would I find Chinese now? Currency modifiers, 116 modifiers. Probably Chinese is then graphemes or something that I have no idea about either. But maybe I don't need to have an idea about that right now. Okay. Yeah, who knows? Okay, is there anything else? Probably not, huh? I've been looking at this so many times. It's considered, returns whether the specified character is considered a Unicode alphabetic code point. That's something I tried, but this then totally didn't work for dashes, for instance. And I didn't like the idea of doing, of having this kind of special handling. Yeah, so I guess we can assert that C is smaller than that. And I'm wondering, do I want to have... Yeah, let's make it a debug. Assert. So this is what we do. No need for a surrogate pair. As this class or category is only 8-bit. All right. This is that, huh? This also means we have to change the control character to something that we don't currently use explicitly. So what about 9E? Yeah, let's have a 9E then. I think I have to use this because control characters want to have the U specification. And this now is here, it's 009E. Like that. And the YAML implementation we could actually make so that it uses the X1 009E for 8-bit and everything else. And, you know, then it uses U and capital U for 16 and 24-bit respectively. And that's what we have here, huh? We have 24-bit. Yeah, that's... Oh, interesting. No, wait, that's not the way we escape stuff. That's how we escape stuff. So it's lowercase u, then uppercase U. Interestingly, it tells you it uses 8 hex digits here. But give me a break, right? This is not happening here. So this... Oh wait, here it is happening, totally. Two, 4, yeah, totally. Okay, forget it. Yeah. Totally works. Okay, so that's how we are going to do it for the YAML implementation. So now we should fail because of YAML, not because of JSON. That's what I'm trying to get at. Cool, that is true. And considering that we exactly know that this is going to be below 8, you know, here we can test for below 65K or below full 16-bit. But for YAML, we can do it the other way around. Well, not the other way around, but here we can even go as far as it's below 60, as below 8-bit. like this. Let's test it. Let's be sure. 0x100, like that. Awesome. So in this case, we want to print 2 and then x and capitalized stuff as you ate. What's the overflow semantics with as? Rust as overflow. Integer overflow checking. Huh. Rust conversion overflow. Rust type conversion from int to string? No. And what does overflow do? If you cast u into u64 or int, you risk overflowing into negatives. Assuming, yeah, the size of a un is okay, blah, blah, blah. This works. So how can I assure that there is no overflow? From uint removed from std_num. Really? So if I have u8 primitive, is there some conversion that I can use maybe? Count ones. Is there full up 0, 1 from string? Zeroable, sub, mul. I would expect something like into. What's not? Oh, like a Boolean not, huh? Lots of stuff. Doesn't need to panic, I just wanna know. Into. There's no into. Ah, here, here's some checked stuff. Maybe one could use a checked add. Start with the 0 and then do a checked add of a u8. Oh well. That will then we'll have to convert and then it can overflow. Damn it. Swap bytes from big endian from little endian makes no sense here, huh? Yeah, interesting. Shift, left shift, right shift. Next power off, overflowing add. Interesting. I don't know how to do that. I can just assume that this will naturally work. Okay, let's try that. After all, this should actually be the solution to our problem here. And make this compile. And that's all we do. Boom, this totally works. So what happens if I try to let foo be this as u8? Does it overflow? This should overflow, huh? This should panic. This should do something. It didn't. So what happens then? There is no overflow protection here. Int rust int conversion overflow. Damn it. Here I'm sure I've been, oh no, that's old. That's better. Do we have conversion here? And perhaps most or all use of as can be ergonomically added as methods. The precise form of this will be resolved in future. No, wait. Making as to be checked. This RFC originally specified that using as to convert between type would cause checked semantics. However, we now use as a primitive type operator. The decision was discussed. The key points in favor of as is original to its original semantic where it's low level. As is the only way to convert types in constants. Hence it's important that it covers all possibilities that constant might need, eventually const fn, blah blah. The type description RFC set the precedent that as is used for dangerous coercions that require care. Okay. So what's the matter now? How do I do it? Okay, I don't know how I create a checked conversion. You probably have to check, right? You have to try it like that. So I can just assume that this will totally work now because I verified this. So that's my debug assert, right? Maybe I should make it an assert. But on the other hand, why would I? If there's no bug in CS control, let's make a debug assert, or let's keep a debug assert. Debug assert, I don't know what I'm talking about. 46 minutes in, and it works. That's very nice. I think that's all we have to do. Let's make a note here. Wait, that is, yeah. No need to handle the 16-bit and 32-bit cases as we don't know them. There are plenty of unprintable characters, but figuring them all out is difficult. According to serde-yaml, Chinese symbols are unprintable, even though they are not. There we go. And we just don't do it then. If it's definitely a control character, it's fine. Everything else is just printable. Even though there are some formatting characters that probably you also don't want to have in there. On the other hand, if it helps an editor to understand what's going on, I think this is totally all right. So that's just the last few control characters that might be there. And we kind of handle it here or test it here. And that is that. And there's no surrogate pair here. And we are good. So this is now, that's the way. That's it. I don't see more to be coming here for now. Maybe tomorrow I see it differently, but I think we have implemented the escaping correctly. And the next thing we can do is try to figure out the details that we actually have to handle. Oh, yeah, let's do this. Feed serd, sir. Handle control characters. Implementations. Control character escaping. I might want to add escape control characters as identified by Unicode. This covers just a few remaining. Actually, this is something we might want to add here as well. That these few remaining ones, how many are there? 60, huh? How many lines do we have here? That's kind of the escape characters we have. 37, so we would kind of double our amount of items. Yeah, forget it. This covers just a few remaining control characters, both for Jesus. Something is going on out there. So anyway, this covers just a few remaining control characters, both for YAML and JSON. Everything else is considered printable, which is nice for things like smileys and Chinese and Russian, which totally show up in your editor as they are. Probably works for Arabic as well, with right to left writing and stuff. Yeah, we might want to, something we might want to try. Skip CI. So let's try that real quick, because this right to left stuff, no idea. How I would do that. So I guess first I want to have some Arabic keyboard. Korean, Portuguese. There we go. I have no idea. Well, PC. Who cares? Just some Arabic, please. Awesome. Switch it. And now we go ahead with we are still left to right. And we should do that many, I suppose. Jesus. That is very, very small. And I wonder if that is a valid identifier for Rust. Let's try that now that we are here. Oh, I can't type let anymore. Ha. Yeah, let's just type the characters then. Let this be... Oh, that was my attempt to write numbers. Also didn't work. Good. Let's see if that works. Okay, so first of all, let's take these two characters here. And second, let's get rid of this. And let's see what this does. YAML dump. Come on, where's the dump? Dump. Here we go. Yeah, that didn't work. Now we go. Cool. So that's the character here. That's two characters after all. Yeah, we might be fine with one character. Just to show off. Oh, actually, that is also, now we have Arabic, and that is 6.3. Oh no, wait. That will remain unchanged. Maybe there's a football game outside. Probably it's barely visible on microphone. Visible. It definitely is not visible on microphone. It's not audible on microphone. Oh, yeah. But it's very audible for my ears. All right, there we go. This should be working now, right? Just another test. Nothing special. Non-ASCII idents are not fully supported. At least it can, show it. That's okay. Probably it is related to the question on how to mangle symbols and stuff. So if you start doing that, then you can't export this to C anymore and things like that. Okay, cool. Look at that. Beautiful. I think I want to amend this commit. And we are good. And the thing is, if we do this in Python... Oh, no, wait. Actually, I'm not totally sure if this string will end up being... If it's just what I see here. Because it escapes by default. Yeah, you actually don't know what you see. Because this could as well be the original character but escaped. So of course, if I paste this in, it will show me what I had. But I'm not entirely sure. YAML load. Voila. But apparently it can be displayed properly. This will work. I'm just not sure if this also is the case here. So is that a string for him? It is a string for him, yeah. So yeah, I think he does indeed escape these, which sucks for YAML. It's kind of a very Western format if it does that, and we are much more, I say we are much more open to the world and to the variety of languages, and I think what we do here is good. Yes, I like. So this extreme escaping is something we just don't have to do. Boom, shakalaka. There we go. I think that concludes the session for today. That's awesome. I think about what to do tomorrow. And actually I know already, because there are so many different features to be implemented here for the mappings and things. And yeah, that's just a little bit of logic. And we might even get to the point where we will attempt to handle... Oh, wait, I forgot. I want to have a refactor around here. So let's refactor, because I would like to have this within the loop here. Because I see it coming that we need to do, you know, when we need folding, we have to adjust this, right? Maybe I do it when we need it. I will do it when we need it. Because that's the analyze part here, sure. But if you look at the folding code, I'm kind of getting ahead of myself again. I think here it does folding, right? If it allows breaks, and maybe if some width is, yeah, see, if some width is satisfied, then it writes some indent. YAML emitter write indent. Interesting. So it writes this indent directly. And what's the move string doing? Actually, this is something I don't know. I want to terminate this session, but also I want to know what move does. Ah. So it moves it one character to the right. More like an advance or something, a cursor advance, because that pointer, that's the cursor. It should be called cursor, I think, because I know it has a start and an end. But this is more like the current cursor. And if it's advanced by the width of the string, that it kind of figures out automatically. Width is width at 0, and width at 0 is that. Interesting. I don't know why that works. Probably is totally related to the encoding and stuff that we don't have to deal with, fortunately. But yeah, so this is why it advances by that amount. So that's the cool thing about this system, lib-YAML here, is that the entire encoding of the Unicode characters like UTF-8, 16, 16 or 32 is handled kind of under the hood, even though I don't really trust the endireness of this thing. That's really something, because I think the bomb handling here is totally it can't deal with the endireness of the underlying stuff. Look what it does. Man. Huh. It's very interesting that this works. Or maybe it doesn't need endireness. Maybe it just deals with UTF-8 encoded stuff by default, and that's kind of how it's handled. And this is why that actually works. I don't know. Or UTF-8, UTF-32. I don't know. But it has all these different sizes, right? 24, 32. I don't know how that works, honestly. Anyway, I don't have to. Yeah, the folding. That's something we will try tomorrow at some point, but I will do everything else first in the sense of mapping handling, right? Let's see, maybe indentation. Something. You'll find out tomorrow. Thanks for watching and have a great day. Night.